quick review about regression. We're doing 6-8. This comes up in the homework, so I thought I should talk about it. Quick review of something. If I see a graph, we're doing exponential and logarithmic regression. So that means the curves are going to look like that or like that, right? They don't have to be a straight line. It doesn't have to be linear, just like with the quadratic. If I see a scatter plot that looks like this, what's my r squared going to be close to? Do you guys remember that r squared is how well it's correlated? 0 means none, 1 means perfect. So what would this one be about, do you think, when I look at it? I'd say that's like 0.95-ish. So it's closer to 1, right? You see it? What would one like that be? This one would be probably closer to 0.5-ish, right? Actually, that'd probably be close, like better than that. I'll put some more dots. There we go. Great. Ring a bell. Remember we played the game. And lastly, this one would be pretty close to 0, because I wouldn't even know where to draw a line on that. Okay, so that's the first few questions the homework are going to ask you to guess the correlations here, 0.5, 1, or 0. A 1 means it's really looks like a good fit. 0.5, not a great fit, but it fits. 0, nothing. And also a reminder, in here, r squared has to be greater than 0.75 to be good. All right? Sound good? So that'll get you through the first like 3 questions of 6-8. Will be guess the correlation of each one. All right? All right, now let's get to the fun stuff, the story problems. All right. So we're looking at the amount of EVs used in a certain region. Y is the number of EVs, and X is years after 1990. Be careful in the homework and the test. You have to pay attention to that years after. You know what I mean? So they give us this equation. If you want to know what that looks like, what you guys are used to would be, right? That's not approximately equal, it is deep. All right, first question. Is this model a good fit for this? What's my r squared? Is it greater than 0.75? Yeah, so that's a yes. It's a great fit for it. All right, what does the model predict the number of EVs to be in the year 2020? So I'm just going to plug it into my equation. Do I plug in 2022 into the equation? No, what should I plug into that equation? 30, because it's years after 1990. All right, plug it in along with me, play the game, make sure that we know how to do this. So I got approximately 73.99 thousand, right? Because it's in thousands. Yeah. How did I know to plug it in? I was looking for the amount, it gave me time, right? I was looking for the A, it gave me the T. Sound good? All right. What's the bottom question then? Is it probably something like, oh, I guess I had space to write this. When does our model predict 500,000? All right. So here I'm looking for what year, right? I'm looking for year, and it gives me how many EVs. So I'm going to do 500 equals 4.28 E 0.95x. Or T, you could plug in a T there if you're used to it. So once I have that equation, is there anything new here than what we just did for the last three? No. Divide by your 4.28. Divide by your 4.28. I got once. I'm going to leave that as a fraction. Is there a benefit if I leave that as a fraction here? Yeah, I'm going to. Is my exponential by itself? Mm-hmm. Natural log both sides. Those are going to cancel. If I'm working with decimals, how many decimal points do I have to use to get it right? At least 6. Yep, thank you. So I'm trying to avoid decimals at all point. I'm going to plug it all at once. It's going to be messy, but life is messy, and that's okay. By 0.95. That's actually quite a growth rate there. Oh wait, 0.95, right? Yep. There should be zeros in all those things. That's gonna make a huge, because that'd be a 95% growth rate. That'd mean it doubles almost every year. That'd be wild. Wild. All right. And then we're gonna plug that in. I'm gonna see what I get. Any guesses? I got X is about 50.11. So what's the question asked? What year, right? So what year would that be? 2040. Because it's how many years after 1990? Like if I asked starting at age 35, if you invest this, what age would you be? Questions on this one. Very similar to what we just did. It's actually exactly the same. The only difference is it's a prediction, right? I'm going to hold off on that one. I just want to do this one. I'm going to do number 3. If you want to do number 2, I'll flash the answer up on the screen at the end, and you guys can check it if you want to try that one on your own. It's going to be the same process, though, that we just did. Everything's going to be exactly the same. This one's a little bit different. This is actually, if you do any sort of sound engineering, they are logarithmic functions. They look like that. That's actually a new tech in a bunch of speakers for some time. So based on the loudness, Y is sound level, and X is the distance from the speakers. Closer to the speakers, the louder it is. As you get further, it tails off, right? First things first, does this fit the data well? What's my R squared? 0.45. Is that a good fit? No. All right. What sound level is predicted at 5 meters? So am I putting in the 5 for the X or the Y on that equation? X was distance. So I'm going to plug it in for my X. There we go. I'm going to just plug it in and see what I get. I got 96.16. Which is actually still quite loud. It's actually really loud. All right, at what distance would it drop to 85 decibels? All right, so now I'm going to switch them. I'm going to have 85 equals 110 minus 8.6 log of x, right? So we haven't done one of these in a long time, solving for a log. That's why I want to do this. Oh my gosh. So steps are still true. We need to first get log by itself. Good writing. 2. Now, to get rid of natural log, we have to take as an exponent. And then 3 is algebra. Bless you. Good old algebra Tim is back. So, right now, do I have the log by itself? No. So I'm going to rewrite up here so I have more room to write before I go wild. I'm going to subtract that 110 over. What's that? Negative 25. Still not by itself, right? So I'm going to divide by negative 8.6. I don't know what that is. 2. Ooh. I'm going to leave it as a fraction. Why is it a benefit to leave it as a fraction? Then your I don't have to worry about decimals. If I wrote that decimal, I'd have to do 2.9069767. All right, I could write that as a decimal. All right, you can do that. How do I get rid of natural log? What's the inverse of natural log? So to get rid of e to the x, natural log of e to the x is x, right? Same thing as e to the natural log of x equals x. They're inverses of each other. G of f of x, f of g of x. So how do I get rid of a natural log? I could use my log rules, right? My base is e. E to that equals x. Or you could think of it as you're taking both as a power of e. Make sure if you're plugging this in your calculator that piece is in parentheses when you're taking it to the power. And then these will cancel. And that's my answer. I got 18.3 meters. Hold. 18.30. It told me to round to 2, so I'm going to do 2. All right. That's 1 second. If you did the problem on your own, this is for these would have been the 2 answers you got for number 2. So you can go through and check it. All right. Enjoy. Thanks, guys.